Hey, my name is Kevin Liu. I'm trying to build a startup in public. I'm trying to build a software that helps farmers plant their crops. Specifically, I'm looking into ways that can help farmers um, plant polycultural crops, whereby if weather goes one way or the other, either way, the entirety of the crop yield that year will be well hedged. So that's my basic thesis. The reason I'm building this in public is to really show my thinking process. Hopefully, this takes off. A little background on me: I have a degree in environmental science and policy. I am the current CTO of a prop tech company. I think the prop tech company is reaching product market fit, and I'm fairly confident it will reach that within the year. So just planning on building things that are more passionate. I'm currently allocating about an hour a day, an hour, 2 hours a day on this software. And I just want to do this in public. Couple of things. So what can we expect? First off, what is Verdant? So Verdant, really, I am at its core is I'm ingesting climate data as well as yield, crop data, and looking to sources, scientific sources of how various environmental factors impact crop yield. And basically use all of that and combine it to help farmers plan their upcoming crop, and plan their rotation. Have a bias toward regenerative farming because, when I was going through my master's, I looked into this a lot, and I think that's moving forward is the way to go. And don't remember a lot, so majority of this will be me researching and building a plane mid-flight. It's basically what it is. So this idea came to me last weekend, and I have some background in fintech as well, and this idea called hedging, which is basically insurance. You buy some options and basically bet somewhat against yourself in a way that if it goes up, you make money, but if it goes down, you also make some money. So it's like really well risk adjusted way of investing. And I think I was thinking about that, and I was also on the side viewing YouTube videos on how American farming practices and how we're now growing our food. And I was like, wait, okay, so we're growing so much corn, we're growing so much of these subsidized crops, and we really can be growing a lot more nutritious foods, and I think they might fetch higher value. Obviously, there's going to be a supply chain issue, but ultimately that's the vision I'm working toward, is to help farmers plant better, make more money, and at the same time feed the public with more nutritious foods, rather than just cranking out corn and making high fructose corn syrup, all of that good stuff. Very grandiose, I understand. So just started 3 days ago. Yeah, I've picked the tech stack. Again, I think tech is a way of accomplishing goals collectively. It helps inform our decisions, so not placing too much emphasis on primarily going to be scientific driven way, and then we use tech to empower. So I started looking at a few data sources, and found some good ones. 1 degree longitude, 1 degree latitude. Fidelity. I'm not sure what. So probably have to find better. That's like around 62 miles of definition. Could be good enough, most likely not, on some of these data that's provided by NOAA. So yeah, I've started working on this a couple days ago. Just I started working on a pipeline that ingests these data from NOAA, and I'll start mapping that. And I've also started looking into USDA data on the yield. And I think, I'm not sure if these, even county level, does it provide enough certainty to help at least predict or inform crop yields of different crops? I don't know the answer, but we'll find out. Okay. Tech stack wise, I've chosen Supabase. I've been building with Supabase for a while now. Really love the company. I'm very familiar with Postgres, and I think it's just one of the easiest ways to interpret data as well. We're all somewhat familiar with two-dimensional table, and it also has a ton of very rich plugins that we can use, extensions that we can use, time series, PostGIS. These are all going to be very useful. So, and then front end, thinking of Versa. Again, this is just because it's a tool I'm familiar with. And also because the DevOps just so well optimized, I can push changes basically every 3 minutes if I want to, and I can fix errors on the fly, make adjustments on the fly, A/B test, all of that good stuff. So scalability and all of the things that you can look into. And Next.js. And then for the ingestion pipeline, I mean, a lot of the front end stuff will be handled. A lot of API endpoints that serve the data will be handled through Next.js. But I think I've decided on Fast API as the backend for ingestion and the analytics. Just simplicity of use. It's also the preferred tool that a lot of data scientists use, so I think I'll have less of a problem finding people to work on this with me in the future. So it's going to be a good thing as well. All right, so that settles tech stack. Again, all of this is optimized to ship code quickly, be as generalized as possible. Perhaps in the future we can specialize more so. And I've already made this decision a couple days ago, so this is just backfilling this part of the log. I've already done some work in the ingestion component of this. A lot of the data that Noah provides if I can find it. These are all in NC format. So NC format is kind of a self-descriptive it's a scientific file format. It's self-descriptive. All of the important stuff is in the header, and then it's sort of vector-based, array-based, multi-dimensional array-based format. So, I'm going to be saving a lot of time by building an ingestion pipeline to sort of take this and map it into a Postgres compliant format. Not Postgres, just a table format. Still have to think about whether that's a good idea or not. Whenever you map a multi-dimensional array into sort of whenever you do a dimension reduction, I think there's a lot of caveats that come with that. Let's look into that. Yeah, well, I've already done some work. Let's change this to me real quick, and let me pull up my Postman. Cool, back at it. I've already done some work on this. Essentially, it ingests a URL and or a list of URLs, and returns either the raw data or the header. Moving forward, I'm gonna have to look into more of the So I'm thinking about this particular thing right here. It could be that it doesn't really save that much time and automating for the sake of automation, but for each data source, I want a consistent data pipeline, ingest from raw file, process, understand the metadata, register the metadata, as well as record the final output in a mapped way that can be stored in a Postgres table. Let me think about this. Okay, this is new territory for me. Again, I'm building this plane mid-flight, so it's as much learning as it is building, which goes back into the format of this. A lot of it's going to be just me staring blankly into the screen, and you're just sitting there and just being like, what is he doing? But to be honest, this video logging of me building this is more so for myself than for you, but hopefully it can be for you as well. So there's that. Okay. Had a little scare there. I think we can store this efficiently. Multi-dimensional arrays. So let's just take a look at some of this data here. I've already built a way to ingest and process data. So, all right. What happened here is I gave it a link to the netcdf file, and it returns the header. It's quite detailed here. I don't understand the shape here. So I'm going to ask ChatGPT. Cool. Now we got this header back. Just take a look. Quite detailed. It's got the shape of SSI. Wavelength, time, so I guess this is daily, should be. Which day is it? For the entire year, okay. Is that what it says? It's got the time dimension, it's got the wavelength. Got the time bound. Okay, need to understand this part better. Wavelength of the solar spectral irradiation. Okay, so this will be important because it could be a measure of the amount of energy that hits the plants, which is what converts electromagnetic energy into chemical energy, that is sugar. Anyways, so yeah, that's important. Well, we have this endpoint built, and same thing here. If we get the actual data, we can also ingest the actual data, and this file's a little big. Let's try to solve that. Okay. We can solve the actual engineering as they go. Let's see. Or perhaps it can go directly. No, I want this to be available to any service rather than being bound to a specific data pipeline. Even if you can specify various data pipelines, I want to be able to explore new ones. So let's leave that for here. Potentially new endpoint creates stable return loading climate. It's okay. This part I know that it can handle multi-dimensional arrays, so that so the plan is to essentially I have a file here stored that's smaller. That is the precipitation data, the daily precipitation data. So the idea is to sort of it's stuck. So to be able to look at this, this precipitation data. Okay. So the pipeline I really want to build is one way or another, we load in so that's a place where file of any file type can be stored. And then trigger a process. Okay, new or existing pipeline. So idea here is I would have already built a table and each file we append here that would trigger some kind of process, maybe through webhook if that's available in Supabase, and it would analyze this file just by hitting this endpoint with the file URL, getting the header, and then getting the raw data, and then based on those two plus any existing knowledge we have on this specific data, it would load that into, say, the GPCP data. And then that data then will be available for us to use in predicting, well, less so predicting, but estimating a range of yield for a specific longitude and latitude, and the precipitation data for that year. Now, let's do a little bit more business side of things. This is more demand component of it. Would farmers find this useful, really? Specifically, I think that a lot of farmers really have a good idea of how to run their farms. They don't need this black box and some scientist off in the field, off in the distance, telling them, oh, this will make you more money. Who are we to tell them what to do? I don't know how to spell orthogonal. I think if oh yeah, I also have to find the first person. I'm in New York City, y'all. I don't have access to person who run the day-to-day of a farm. So I really need that as a test case. Not a test case, but, well, yeah, a test case. So if we say, all right, you should grow X amount of lettuce, X amount of wheat for maximized return, the farmer's like, no, I know my land, I know my equipment, and I know my bandwidth. This really isn't a good idea. So what happens then? I think the default assumption here will be, no hypothesis, if you will be that we're wrong, right? And then this part I really need help with. I'm gonna reach out to a few friends, see. I know a few friends who grew up on a farm. Hopefully they still have connections with people who still run day to day on a farm, preferably someone who grows food. I know who this person is. For his privacy, I'm not going to reveal that. So I went to grad school for this, so I'm sure I can get in touch with a farmer who's willing to help and provide feedback. So no hypothesis. If another issue with this idea is, what if we make the wrong recommendation? There will be liability. Well, firstly, there's gotta be a disclaimer, right? Connecting would that work? A peer-to-peer analysis of the report generated or the recommendation generated to run a sanity check. Now I think about this. All right. To do this, I have to pitch this, right? Okay, this goes back into what problem am I solving really? Today's Thanksgiving, so I'm not gonna bother my friend, but tomorrow. this is basically what this should go somewhere else. How much time do we have left? Closing on the hour. I think in about 20 more minutes I gotta put the turkey in the oven and celebrate Thanksgiving. This part, I'm also a little worried. I really want to do this, but I'm not sure if farmers recognize soil health as an issue. So we'll put a pin on that. I think I'm happy with this problem solution for now. This is obviously subject to change because this could be that it's not true, right? No, we're not really losing money because of variability. We're losing money because the seeds are too expensive. We're losing money because we banned because foreign goods are flooding the US market, so we can't sell it at a good enough price, or if China bans soybean import. Those are economic driven reasons. So it could be that near future would pivot toward sort of simulation, like Monte Carlo simulation on the price trends and some kind of simulation on the profitability of a specific crop. But because we're going to be building climate data into this algorithm, it's going to be factored in already. So I think the path we're on, it's good. So we factor in climate data, economic data, as well as the yield data. And further down the line, we can specialize in one data or another, or it could be a combination of three that proves to be significantly helpful to farmers. So yes. Okay. I'm happy with this for now, and I'll reach out tomorrow to my friends and So during my previous startup, I had a tendency to reach out to those I know, those I think have, at least those with perceived credibility or knowledge of the space I was in. For context, is this index, and sort of test the idea. I think the idea to this day is pretty good, but I don't think we ever had that slap in the face feedback. Oh no, you're really executing this wrong. You're not running this correctly. You're not going lean enough. You're gonna die soon. And eventually we died, right? So at this stage, I really want to seek out criticism beyond all. And maybe with their permission, the people providing the feedback can also join us as a podcasty type of thing. Just basically provide that feedback live, and I will react live and continue to fine tune this idea or the model and the approach I take to building this software and service. Cool. I am going to dig into the economic data a little bit more so that I can at least think about, because ultimately this software is not going to work if people aren't actually, number one, boosting their profit, or at least perceived that they would have lost more money if they hadn't used our software. And in addition to that, we have to find a way to monetize this service. I don't know. That's a good thing to jot down. Just a little idea here. So ultimately, I'm not trying to run there are a lot of fundamentally unprofitable businesses in Silicon Valley, and I'm really trying to avoid that. So, gotta think about this in the long term. How will we make money? So, in order for us to make money, we have to pick our initial clientele, and I really want to target these distributed farmland owners, farmland operators. I think I will likely be able to make more money from these larger institutional owners and operators. Maybe I'm having some lofty sort of aspiration of bringing more farmers back into America and just some ideological stuff. I want to target the distributed users first, and I suspect in order to make money at some point we'll have to target institutions, but let's leave it at that for now. We'll find out. So ultimately, to convince operators to use our service, there needs to be either and or year-on-year profit yield or yield growth, or year-on-year loss reduction, which would also translate to the above. Yeah. That there are multiple levers that can be pulled here. So yeah. So basically, at its core, we're either saving farmers money or making them money, and we'll take a percentage of that delta. So at its basis, make the amount of money we make just based on just common sense is that it cannot be more than the cost savings or the profit boost. So I can't price this just yet. The good thing about the venture capital, though, is that in the absence of correct pricing, there are still speculative and visionary investors that can say, all right, there's a good chance you'll be making a loss for the next 3 years. But once you find out how much is the sum of savings, how much efficiency are you bringing to the table, and what percentage can we realistically charge, at that point, will be a profitable business, and we can sell it at a high multiple to the secondary market or to an institution that can use this. So again, more of a discovery process, but right now I'm just setting up a mental framework in how I plan on thinking about this in terms of a business, and where I can look for sources to justify all of these. Everything so far is a question mark. And we should perceive it as such. Okay, the to-dos: reach out to my friend to test the idea, reach out to grad program to test the idea, actively seek out criticism, and I'm comfortable with this today. We're hitting up coming up to the hour. I may continue to work on this and think about this, may not. Looking to I think I'm going to use USDA primarily as a way to as an economic data source. For this to work, there's got to be a core algorithm that's crop specific, location specific. Of calculating profit and yield. So this algorithm, we're taking climate data, we're taking reason we call it Verdant AI is really, number one, it's a buzzword. Could help with valuation, but really, I think a large language model, if you inject it with the right data, so far from what I've seen in analyzing profitability of real estate portfolios, it has done a fair job. So I think AI will be able to help explain why various strategies are the way they are. I plan to have a knowledge base of various scientific paper, which often are not that easy to read, and scientists may have a great insight into why a certain farming strategy would just maximize yield while minimizing costs. But if they write it in this very lofty language, hard to understand language, there's no one that's going to be able to, not be able to, but willing to adopt that strategy. So I think AI will bridge for adoption. Hopefully that's the case. So once again, this is a question mark, but that's at least my reasoning behind slapping an AI in the name. Hopefully that makes sense. Now back to the algorithm. So we have climate data, we have economic data. So how much ultimate value, what the cost production is, and then we have so the algorithm itself, which I think will be the core. I'll think about whether to open source this or not. But the algorithm itself should be flexible enough that it's not just an Excel sheet, right? I suspect it's fairly simple to just build an Excel sheet, loading some basic
crop data, and then you just adjust
various inputs. I think that this algorithm should be flexible enough where it can ingest new data points and influence the weight that will ultimately impact the crop portfolio, because we're really there's so much science that's being done, and our understanding of agriculture is continuously improving. I think right now it's an adoption issue, not a understanding issue, and our job really is to bridge that gap. In doing that, we need to be flexible enough to incorporate new understanding, scientific understanding. So but with weights, the difficult part is interpretability, right? Why does it increase the weight in one way or another, or decrease it, and for what reasons? And without a good understanding of that, that actually works against adoption, because you can't just tell me if I adopt this new strategy, it's gonna 2x my yield without telling me why. Of course, we can cite the paper, but why is it 2x? Why is it not 1.15x? So a lot of that. Isn't there a mechanistic? This is a word, right? Okay. I just don't know how to spell, I guess. Alright. So I think I'm happy with this today. Going to get back to Thanksgiving, and I'll see you guys tomorrow.